Hello, class. How are you? So here's the beginning of Chapter 7. That you're going to get a little bit of a video presentation here to be continued in class. So what we're going to cover this chapter, up and coming, is rational exponents, radicals, and complex numbers. We're going to start with radicals. Start smack in the center. And you might know radicals more as roots, like square roots or cube roots. So it all begins with, you know how math you do, you add, so you subtract. You multiply, so you divide. So it's this idea of opposites. Well, with roots, it's the opposite of powers. Exponents and powers are opposites. So we were all pretty familiar with the term 5 squared, which means two fives multiplied to each other. So it's a kind of multiplication, a shortcut. So, which we know to be 25. Yeah? Well, let's go the other way now. So you start with 25, and you use the hat, which is the root symbol, which means what number times itself is 25? And the answer is 5. It's just the opposite of 5 squared. And likewise, let's go up the chain a little bit. What's the square root of 36? What number times itself is 36? And you would reply 6, and you'd be correct. So these numbers that come out so nice are called perfect squares. Numbers that come out to nice whole numbers. So we've looked at these perfect squares. What happens if the number that you're finding the square root of is not so perfect? Say the square root of 30. But we can pretty much know where that's at. We know what the square root of 25 is, 5. Square root of 36 is 6, so it's somewhere in between. What is it exactly? There's the rub. There is no exact number, because you can't write it as a fraction. Hence this idea of it's an irrational number. So you might have rational or fractions. Irrational means you can't write it as a fraction. But we can get darn close using the trusty calculator. Put that in a calculator and you get 5.49 blah blah blah. It goes on forever because you can't write it as a fraction. And it doesn't repeat. But for us, for our purposes, again, one place ought to be fine. And if you round it, 5.5 ought to do it. It's real close. If you do 5.5 squared, you get really close to 30. You get a little more. That's why the answer is really 5.49, etc. So those are the irrational numbers. Most numbers are irrational, but we play around a lot with the perfect squares. Now the square root, when you find the square root, it's always positive. So when you see the square root of 25, we're always looking at positive 5. Even though minus 5 times minus 5 is positive 25, still when we talk square roots, that isn't implied that there's a plus in front of there. How can you get a negative 5? Well, if it's the square root of 5 with a minus in front, then you get your negative 5. But that's the only way. So when you take the square root of something, even if it's something like the square root of negative 3 squared, basically that means you're taking the square root of the positive version. And even though the square root and the squared, those guys kind of cancel each other out, but that doesn't leave you with minus 3 because it's always positive. So the answer to this is 3. It's a little, a little thing, one of those little things that we deal with in math. So, and that'll come in later. We'll look at positives and negatives. When is it negative? Well, when can it be negative? How about this? What's the square root of negative 4? You're not going to find a positive or negative answer. It's going to be positive. It's got to be because it's square root. But that negative 4, can't do it. That's one of those things where, what does it give you? It's imaginary number. What does that mean? Imaginary number. That is not a real number. So when they talk about real numbers, the square root of a negative number isn't real. So almost all the numbers we work with this year are real numbers, fractions, decimals, whole numbers, square roots, like square root of 5, but not the negative. Square root of a negative number is a very specific thing. They're also called complex numbers. So complex, we will deal with them in 7.7. That will be coming up, but not yet. So that's for us right now. We're fine. We can stay away from those, but we will deal with them. And they deal with them in some of the other math. It's like electrical engineering deals with complex numbers often. So when you can have a negative underneath the root, would be not square root, but cube root. So when you see this number over here, ooh, that's an arrow. Wait, that wasn't very good. When you see that 3 over there, what we got here is, trying to make this, that 3 tells you that there is it's the third root. If nothing's there, you assume it means square root. But once there's a number in there, that tells you it's the cube root, which basically means what number times itself 3 times, or 3 of them, that gives you negative 8. Well, 2 times 2 times 2 gives you 8. And it can be a negative here because there's a negative inside and it's an odd root. So negative 2, and then to prove it, just to go minus 2 cubed, notice the parentheses, which does indeed give you minus 2 times minus 2 times minus 2, which is minus 8. So checkarunio. Now, we're going to be dealing mostly with square roots as this particular chapter, because they come up more often in some of the formulas that we might use. So you could actually see something like the square root of 9/16. How do you do that? Well, you could turn it into decimal. You could always use your calculator, do square root and then parentheses 9 divided by 16, and that will spit out the decimal equivalent. But you might notice that what we have here is a fraction that is made up of perfect squares. 3, that's the square root of 9, over the square root of 16, 3/4. And that is indeed what you get, the square root of 9/16. So if you did it in decimals, you'd get up 0.75 as your answer. So how about if it's a square root of a much larger number? That would be hard to find. Well, use your calculator. That's a surefire way. But in case you didn't use your calculator, you want to do it in your head, well, you know that the square root of 100 is 10. And you know the square root of 400 is 20. You know that, right? I mean, that makes sense, right? Because 20 times 20 is 400. 10 times 10 is 100. So 289, square root of 29, is in between there. Just like between the square root of 30 was between square root of 25 and square root of 36. So likewise, I know it's between 10 and 20. And then if it is a perfect square, the only way to get like this 9 here is it's got to either be a 3 times a 3 or maybe a 7 times a 7. And if you try 13 times 13, maybe it's in between 10 and 20, but that gives you 169, not enough. Closer to 400, our answer is, and wouldn't you know, 17 is the deal, because 17 times 17 is equal to 289. So here we are playing with the square root things, but what do we have to do? We got to graph them too. Now, if we set y equal to the square root of x, what you got here is, first of all, let's write it as f of x equals the square root of x. We'll use that kind of function idea. We can do that. We can keep it as f of x and y means the same thing. But what we got here is, well, what does this look like? And how do you graph that? I can't put it into y equals mx plus b form because it's not a line. And so how do we graph it? And the answer generally whenever we graph stuff is make a little chart. Look, I'm using y for f of x. It's easier to write. So, and pick some points. How about 0? Always a good place to start. What's the square root of 0? Nothing. Zero. Zero times zero equals zero, so that's it. How about 1? What's the square root of 1? So what times what equals 1? What times itself? And that's a 1, so pretty easy so far. How about 2? 2 is not so great because it's not a perfect square, right? What times what is 2? And like, let me use my calculator, and it comes out to approximately 1.4. That's not that fun to graph, so let's try to find the whole numbers. What's the next nice whole number? How about 4? That's a good one. Next perfect square. I'm off the chart here. Square root of 4 is 2. That's pretty cool. So let's take a look at that. What does that look like on the graph? So we got 0, 0, smack there. 1, 2, 3, 4. And then you go ahead and you go, we got 0, 0. Here, let me use the blue for that. 0, 0, 1, 1. It's looking like a straight line, but it ain't, because 2 is up just a little bit. And then we have to go all the way to 4 and up to 2. So you see it's got this kind of curve, but it goes that way. It's actually a parabola on its side, if you know what a parabola is. Now the thing is, notice how it's like a half arc over here. How about if we put in -1? What's the square root of -1? No, can do. You can't do square root of negative numbers. So what you got to do is then go ahead and think about that. Remember when we said stuff you can't plug in, can't get 0 in the bottom of a fraction for a function if you're graphing it? So likewise here, what's the domain? What can you plug in or what can't you plug in? I do not want that to ever be 0. 0 is okay. I don't want it to ever be less than 0. No negatives underneath there. So your domain should look like, here, let's get rid of some of these things. Erase, 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 erase. Oh my gosh, gotta erase, erase, erase. So what we want is x to be the domain, and we don't have to use that set notation right now. All we gotta say is the domain, what works? All x that is greater than 0 and can equal it. So everything greater than or equal to 0 is fine. Anything negative doesn't work. So our domain is that, and in interval notation, that would, whoopsie, better erase that, get out my trusty eraser, and let's do it with, let's use the bracket. Interval notation, 0 included can be in there, all the way up to whenever, as far as you want to go, which is infinity. So that is the domain. So now it's your turn. Here's a function over here. F of x equals the square root of x plus 2 minus 4. A little more complicated than the one I just did, eh? But if I said, graph this, find the domain. So you're going to be plugging in points. By the way, that square root is capturing the 2 also. So basically for domain, it might be good to check this out first and say, oh, x plus 2. What's up with that? I need that to be positive. So I need x plus 2 to be positive, greater than or equal to 0. Now you know how to solve these. You remember? What you want to do is say, oh, subtract 2 from both sides. Cool. X has got to be greater than or equal to -2, which is interesting. So it can be a negative number because of the plus 2 that's inside there, but nothing less than -2. So what does that mean? Let's go to our, make a little table here, and let's pick some points. So -2 is a good place to start, because when you put a -2, you get 0 there. But then you look at this guy over here. Here's where that -4 comes in. I didn't care about him for the domain, but it does affect the value. So you get square root of 0 is nothing, and then you get a -4 over here. All right? Let's plug another point in. How about -3? Nah, if you put in -3, you get a -1 inside the square root. That's uncool. The alarms go off. We can't have that. So anything bigger than -2. So let's pick what's a good one? -1's good. And the reason why I'm picking -1, because the -1 plus 2 inside here, let's make some room here. If we want the negative, this guy inside here, you put a -1 there, and you get -1 plus 2 equals 1. And then it's the square root of 1. I can handle that. Square root of 1 is just 1. Take away 4 will give you minus 3. All right, we're working our way up. So let's stay with brown here. What's another good thing to plug in? Well, I can plug in 0, but then I have to deal with the square root of 2. I want to get that square root of 4, so 2 is the deal. Let's stick in 2. And then 2 plus 2, square root of 2 is square root of 4. So square root of 4 is 2, minus 4 is negative 2. So still a negative land there, but let's go one more up. I want the square root of, well, 3, nah, I want the square root of 9 as the next perfect square. So let's pick 7. So that'll be 7 plus 2 is the square root of 9. This 3, take away 4 is minus 1. So even though I'm still in the negative land here, that's enough to graph. And notice my graph over here has gone up by 2's, so I don't want to get all squished. So let's put it in there. And I'm going to change the, now we'll go with the blue one. The blue guy, so we got minus 2, minus 4. Oh, we're going to have to make a little minus 2 over there. So minus 2, minus 4. Minus 2, minus 4 is here, because they're going up by 2's. And then minus 1, halfway, minus 3 is like here. 2 minus 2 is over here, here. And then 7, 2, 4, 6, 7 down negative 1 is here. Let's erase this little guy. So what we got is that same shape we had. It is the square root of x shape we had before. So y equals the square root of x, but it's been shifted down 4 because of that. That's the minus 4 pulled it down. And because of the plus 2 in here, moved to the left 2. So that's like, those are called transpositions. But that's how you graph that. So and what's the domain? What did we say the domain was? The domain is x has got to be greater than or equal to negative 2, which you can sort of see here, right? Because you can see that that's the nothing less than everything's to the right of this. Well, that's a funny thing. So, and what does that mean again? So the domain is greater than negative 2, which we can write as negative 2 to infinity. There's your doe, a deer. And there's our graph. Here's our values. Here's our graph. Good to go. So now, after this, we're going to now head our way into, that was 7.1, all you need to know. Let's check out 7.2.